Good morning, class. This is the third video for geometry. Geometry, of course, it is known for angles, of which so many students are afraid of. All right. One thing about geometry, it forces you to remember the theorems. It forces you to remember the structure of the angles. Yes, how the angles appear. You must always be able to remember them. Otherwise, you'll always think that geometry is difficult. Okay. So we have here the first one. All of them want to find the value of x. Now, when you observe this, we have a straight line. Let's see something here. Okay. Let's say here is 64. Let's say here is 37. And let's say this is x. This is different from this. The only thing that is common between the two cases, here we have a line where all the three angles are. Here we have a line that, yes, the three angles are also on this line. But the difference is that the vertex for angle 37 is not the same vertex for angle x. The vertex for angle 37 is not the same vertex for angle 64. That is the huge difference between this case and this case. Here, 37x and 64. The three angles have a common vertex. Whenever 2, 3, 4 or more angles share a common vertex and all the angles are covered by a straight line like this, we can say they sum up to 180 degrees. We can say they are adjacent angles on a straight line. Whenever two or more angles share a common vertex, we can say they are adjacent angles. And for adjacent angles on a straight line, sum up to 180 degrees. Now let's see, we have this case here. This is x, this is 60. Are these angles adjacent? Yes, they are adjacent. Why? Because the vertex for angle x is the same vertex for angle 60. But are they on a straight line? No, they are not on a straight line, because if we perceive something here, there will be an angle, there will be a missing angle. So in a case like this, they are not sum up to 180 degrees. But here, they are sum up to 180 degrees because they are not only adjacent angles for sharing a common vertex, but what? They are also on a straight line. So we say 37 plus x plus 64 is equal to 180 degrees. Guess what? Geometry, they value the reason, they value the theorem. Why? Because not only adjacent angles on a straight line sum up to 180 degrees, we also have more theorems where we say sum up to 180 degrees. So if you don't write the theorem, it's like this one could be meant for another theorem, could be interpreted as for another theorem. That is why in geometry, we are always interested in the reason. Okay, so what is the reason here? We can say these are adjacent angles. That is the reason. So now we say x plus 37 plus 64, 101, which is 180 degrees. So x is equal to 180 degrees. We move this to the other side. So x is equal to 79 degrees. One good thing about geometry, once you are able to observe the angles, you can remember them, you can remember the structure, and you are familiar with the theorems. The mathematics that involved is just so easy. Most cases is about addition and subtraction. Now, let us come to this one here. The second one. We have here angle x, angle x, angle 50, angle 60, and it seems like no angle is given. Yes, we don't see any number assigned to this, but there is a box. That box is so unique in geometry. Once you see the box, it means 90 degrees. It means this is a right angle. A right angle is an angle that is exactly 90 degrees. So what do we apply here? What theorem do we apply? Because it's the theorem that tells you to say you need to add. And if you are adding, it should be equal to 180. Or if you are adding, it should be equal to a particular number of degrees. Or it is the theorem that tells you that this and this is supposed to be equal. Okay. So whenever you have a situation like this, now let's keep going. Let's do something here. Now, I want to start here. This is angle 50. I keep going. Angle X. I go again. 90. I go again. 60. So my starting point is where I got to, the end of everything. So what do you sense here? You sense a circle. So when you have a situation like this, it means we sum everything to 360 degrees. But we have um, exceptional cases wherein, for example, if you have like this one, let's say this is 90, 150, let's say 60. Okay, let's say you find X here. Okay, now you need to be careful. We are given 90, we are given 150. We need to find X. Here we don't sum to 180. Sorry, we don't sum them to 360. Why? Because now let's see the reason. We start here, angle X, yes, angle 150, yes, angle 90, yes. Do you think we can continue? No, because no angle is given. No angle is given, and this one, nothing is assigned to it. So we cannot continue because nothing is there. Unlike here, if you tend to start here, you cover 50, you cover X, you cover 90, you cover 60, and we are back to our starting point. So this is a case wherein we say angles at a point. Angles at a point, we sum up them to 360. So you say X plus 50 plus 60 plus 90 equal to 360 degrees. What is the reason? Angles at a point. PT, it is accepted, understood to represent point. So X, if you want to start this way, you can even start with 60. The most important thing, you add everything to what? 360 degrees. So now we say X plus 50, 60 is 110, and this is 200, which is 360 degrees. So X is equal to 360 degrees minus 200 degrees. And what is this equal to? 160 degrees. So this is what we have. The last one is here. Okay. To remind us all, here nothing like parallel lines. Here nothing like parallel lines. But here there are parallel lines. This line is parallel to this. Most cases, except otherwise, the examiner, the examiners are always helpful that they indicate arrows to represent parallel lines. Okay, whenever we have a set of parallel lines and a line crosses those two parallel lines, that line has a unique name we call transversal line. It is called transversal line. Whenever a set of parallel lines is crossed by a transversal, whether it is crosses this way, it goes this way, the most important thing is the line crosses a set of parallel lines. So when that one happens, three angles, we have three unique angles we can generate from them. That is corresponding angles, co-interior angles, and alternate angles. But there is a simple technique about a set of parallel lines crossed by a transversal line, which says that whenever a set of parallel lines crossed by a transversal line, especially when we have just one transversal line, every acute angle is equal to any other acute angle, and every obtuse angle is equal to any other obtuse angle. and the sum of any acute angle and another or any other the sum of any obtuse angle and any acute angle is equal to 360. So here we can see x, we can see 40. X is acute, 40 is acute. So they are what? They are equal. Or the other one says, on the same side of the transversal line on the left side, this x is below the parallel line. This 40 is also below the parallel lines. So when this situation happens, we can say they are corresponding angles. And corresponding angles are said to be equal. So we say x is equal to 40 degrees. Do not forget, geometry is interested in the reasons, the theorem, because not only corresponding angles are equal, also alternate angles, also vertical opposite angles. So the reason is what? They are corresponding angles. Just that, this is the final answer. You know the theorem, then geometry will be easier for you. So we have the class stopped here. Thank you for watching. Do not forget to follow, like, share, and comment. You can also recommend the classes to your colleagues. See you in my next video.